All right, today we're talking about sound and light. This you can move if you need to. This is your unit. You can move if you need to. Not right now. You would a little bit. Sound and light is a continuation of our last unit over waves. Okay, is our continuation of our last unit over waves. Our two types of waves we talked about last unit were transverse and compressional waves. Okay, those are types of mechanical waves. They require a medium. Uh, so sound and light is going to be a lot more specific than what we have done. Okay, we know that sound waves are produced by something that vibrates. We can do this by sticking our fingers over our voice box and say something, and you can feel the vibration. Okay. What? What? Say that again. It is your vocal cords that vibrate, but your vocal cords are in your voice box. Okay. This is why when you get strep throat or you get something where your vocal cords are inflamed, they do not vibrate the same way. And if they get too inflamed, they cannot vibrate at all, then you do not make a sound. Yes, sir. I have no idea. Your voice box. I have no idea. I can also make other things vibrate. Okay. Anything that vibrates creates a sound. Okay. A tuning fork creates a sound. You can actually see, if you look close enough, you can see the fork vibrating. Okay. You can see the fork vibrating. And this fork is displaying resonance. I have no idea what sound this one's vibrating at. Okay. But sound waves are compressional waves or longitudinal waves. So sound waves have compressions and rarefactions. Okay. Have compressions and rarefactions. We know that sound cannot travel through a vacuum. Okay, sound cannot travel through space. And we know that they travel at different speeds and different materials. What medium? Okay, we're talking about different materials. What medium does sound travel the fastest in? Solids, because we know they require medium, so they require matter. So our solids have the most tightly packed medium, so they transfer the best through there. That's why you can get a little tin can, tie a rope in between it, and talk to someone. Anyone has ever done that? I figure that's right up Bill City's alley. If you get a tin can and drill a hole through it, tie a rope to it, have somebody stand far away with the tin can and with the same rope tied to it, after their ear, and you talking, yes, you can hear it.
I mean, I've tried it, but we were too close, so I didn't.
Yeah, you got to whisper almost to do that. Okay, you got to whisper almost to do that. If not, you.
They have that thing on the playground. They have the little speakers on one side.
Oh, I didn't know that. What? Yeah, Science Center has those. Yes. And we know that they travel the slowest in air. Okay. If you would hear a gunshot underwater, if you shoot a gun underwater, it would probably blow your eardrum. Okay, that was actually the plot in one of the NCIS episodes, because we know that they travel extremely fast in water. Okay, the sound, not necessarily the bullet.
So the sound, like, did you hear the sound before you saw the bullet? Then?
Underwater, no. The bullet still travels faster. Okay, the bullet still travels faster than the sound does, but you would hear it sooner than you would if it was in the air.
So I can only imagine how loud a grenade is.
What is that?
No.
What happened to your
What happened to your eardrums? It depends. It depends how bad they blow. You can die from it, yes. Most of the time, a lot of time, it is permanent. I mean, it can be repaired a little bit, but typically, like prolonged exposure, you just never get it back to where you were. Okay, depending on what it is. All right, we know that sound travel the faster in warmer media. I know that my house, like in the summertime, in the wintertime, I never hear the prisoners. I never, ever, ever hear the prisoners. As it gets warmer outside and they go in the yard, they spend as much time in the yard, but I hear them more because we know they travel faster in a warm media. I like to think of this like an interstate, okay? We know that temperature is the average amount of kinetic energy, how fast they move, okay? Can you move faster on an interstate, or could you move faster down Commercial Street? 100% depends. That's a great point. Well, the interstate, as long as everybody else is going faster, correct? But if you're stuck in traffic, you're going actually slower. Okay. So the faster everybody else moves, the faster you move. So that's the same way that sound is. The faster the particles are moving, the faster you move. Intensity and loudness. Okay, intensity and loudness. Intensity is defined as the amount of energy transferred by a sound wave in a given second. That's the definition of intensity. Intensity decreases as you move away from the original vibration. So I know that if I go, if y'all move away from me or I move away from you, my sound doesn't have as much intensity. Okay? My sound doesn't have an intensity. Loudness is a scientific term. Loudness is a scientific term. It is defined as the human perception of sound intensity. So going back to our waves unit, if a tree falls in the forest and no one's there, does it make a sound? Yes. Why?
Because it has vibration.
Because a vibration occurred. However, if a tree falls in the forest and no one is there, is it loud?
No.
No.
It's not human.
Because there's no human there to have that perception of that. Okay. Decibels are measured in intensity. Decibels are measured in intensity. I find this very interesting. Most people think that males are louder. Okay. Most people think that males are louder. However, the loudest sound ever made by a person was made by a woman. The loudest sound ever was made by a woman. Sporting events, at the Show Me Center, they used to have next to the scoreboard a thing that measured the decibels. Okay, that measured the decibels, that measured how loud it was in there. Okay, and the louder you got, the more people were in there, the louder you got. What? No.
It didn't actually do that.
Yes, it did.
Then how does it go all the way to the top and no one is yelling?
It does. It measures sound intensity. I mean, it broke down for a little bit. I think they ended up taking it out. Okay, they ended up taking it out. But it's a scale. Okay, 0 being very quiet. You can get above 120. We'll talk about that here in a second. But different things have different amounts of intensity. You don't have to know this per se. Okay, but this is kind of common sense. Okay, this is kind of common sense. You know that a jet plane is louder than, say, your house at night. Interesting thing about your house at night, people think your house at night is relatively quiet, don't you? Typically, when you were sleeping, you still have probably almost 30 to 40 decibels of sound. People snore, okay, if you have your dishwasher running, whether you have your wash machine running, anytime you move, roll over, you create a sound, okay? You create a vibration, creates a sound.
Normal, like, decibels of a human's voice.
I'm not going to tell you that.
Why?
That's one of your questions on your homework.
I remember
It's one of your questions on your homework.
elementary school, they had this like stop light, and like if it got to red, we had to stay quiet the rest
Oh
of
my
the night.
god.
Oh, that's pretty cool.
It was so annoying.
A thing in here that's important is at 120 decibels. At 120 decibels is called the pain threshold. Okay, so at this point in time, at 120 decibels, your eardrum can become damaged. You can have hearing loss. Okay, and that's why you see this is like industry. Anything above 120, you're required to wear earplugs. Okay, prolonged exposure to stuff at 100, 110 can also cause. So that's why you see people working in a factory typically wear earplugs. Okay, construction workers wear earplugs. People on the tarmac, they wear earplugs to help muffle the sound. Yes, sir.
Is that why, like, just going for a car, like, you know how they sell like 12-inch subs and stuff? Is there like a maximum size that they can legally sell because of that reason?
I would assume.
Yeah, because I never seen these subs with normally more than.
In a car, I don't know the answer to that question. Okay, in a car, I do not know the answer to that question. But I would assume that's kind of like with tinted windows, that there is a certain amount of tint that you can do. I do know that. I do know, and I don't know if there's a car that is illegal not to sell, but I do know that like Charleston is a city ordinance, too loud we impound. If your vehicle stereo is too loud or anything's too loud, they go and pound your stuff. So I don't know if it's a universal loudness. That's a very good question though.
But like my uncle when he was younger, like he was a big car guy and everything. So he had subs, and at his like prime time of working on cars, he put enough 12-inch subs in his vehicle and made his steering wheel shake, like vibrate and look like it was waving. Do you think that's high enough to hurt their ears?
Yes. Rock concerts. Rock concerts are notorious for being above 120 decibels and have people having hearing damage after a rock concert.
Yeah.
Call the police and complain. The police come impound it, and then they got to pay. You got to pay to get stuff out of the impound. I mean, I don't really think we enforce it. Some places, I mean, it's kind of one of those things. They want to get you. That's what they're gonna get you with. Go ahead.
I'm having to feel like these people will like play video games for a long time, have headphones in, and have it all the way up, and they'll play for such a long time. When they come and they start, my brother's, and then he'll come home yelling instead of talking normal.
Yes, and that's actually that's a problem that a lot of I can't think of the name. ENT doctors are really worried about is that people with headphones, headphones are a relatively new thing. Like I remember having headphones. They were when I was little, things like that. They weren't very loud. But if you've got Beats and over the ear headphones, they're causing hearing damage. Okay, causing hearing damage. Now, typically we're talking about your brother. It's a short-term thing because the headphones there, his body's having to readjust. But long-term, it's probably not going to be a good thing. And there's also a direct correlation with children. Typically, the louder a child is, the worse their hearing is. There's a very strong correlation to that. If a child cannot hear, they're a very loud person, a very loud child.
Since we were talking about how you said, like, after a while, if you're playing a game, you have the sound all the way up, your head has to get back to normal. So this has nothing to do with sound, but you know how when people go underwater, a couple 100 feet, and they have to decompressurize, if they stay down there long enough, could it physically hurt them?
Mm-hmm.
So what about airplane flights?
The cabin is pressurized to normal pressure, not extreme pressure. Okay, extreme pressure. You actually talk about kind of off-subject topic. Your DNA changes when you're in space. They had a thing last year, 2 years ago. They sent a identical twin to space.
Yeah.
And the other one didn't go, and he came back. It was his DNA was 10% different than his identical twin.
That's crazy.
Yeah.
Mm-hmm. Wait, how's that work?
Your body mutates all the time. 9 months, I think.
It was a whole year.
Yeah. Now, back to decibels, okay? This is when you think sporting events, this is very much a home field advantage, okay? This is very, very much a home field advantage. You want a place to be loud, because if it's always loud, you get used to it. Same thing talking Aiden, when he comes back in, he's getting used to being loud. So football stadium, St. Louis is building a soccer stadium, and they contracted a company to specifically study the sound to try to amplify the sound that a person makes. They have, it's kind of a cool design. They have these overhangs, and the way they are bent is made to reflect the sound waves back into the stadium, back and forth, thus amplifying the system. Kansas City has the loudest football stadium. It was 135, 137 decibels. Unless it's changed. It was Seattle for the longest, but it has changed to. Last I saw it was Kansas City, 135 decibels, which that's above the pain threshold. Okay, that's almost as loud as a plane taking off. It's almost as loud as a plane taking off.
How's that not illegal though?
I mean, how can you make because they have 90,000 people. They've built the stadium. They've modified the stadium to make sure that the sound reflects and amplifies. I mean, it wasn't a sustained 135 decibels. It was just a one, at one point. And people talking, people stomping, anything creating a vibration will go into that. Yes, you want it to be constructive interference. You want it to be in phase, not out of phase. Okay, pitch and frequency. Okay, pitch is the human perception of sound waves. Okay, so pitch is to frequency as loudness is to intensity. Okay, pitch is to frequency as loudness is to intensity. If the pitch increases, then the frequency increases. The average human can hear from 20 to 20,000 hertz. From 20 to 20,000 hertz. You can go to the St. Louis Science Center. I don't hear very well. Okay, if you ever hear anybody's tone deaf, they're probably having some problems with their pitch. Okay, My left ear can hear from 20 to about 17,000 hertz. My right ear can only hear from about 20 to about, I think, 12 or 13,000 hertz. They have a little thing that you test, and when you hear, if you hear it in your left ear, you hit the left button. In the right ear, you're hitting the right button. Very, very cool. I could spend all day at the science center. I would just wish all the little kids would be there when I was there. What? A dog whistle. That's a very good question. A dog whistle is higher than 20,000 hertz. Okay. Dogs can hear a higher frequency. That's why if you blow a dog whistle, you can't hear it, but the dog can in response to its tension.
Can you feel it though? Like,
Not typically not an ultrasonic wave. Okay, typically not an ultrasonic wave, which is above 20,000 hertz. Okay. You also use an MRI when you get an MRI done. They use ultrasonic waves. Same thing with a woman. She has an ultrasound when they're pregnant. It doesn't harm us. It doesn't harm us. We just can't hear it. Okay, we just can't hear it.
So you can't get affected by what blowing the dog whistles or
No, your dog can't. It can blow your dog's eardrum. Sound waves below 20 hertz are called infrasonic, and they can't be heard by humans. Those are typically things that you feel. Okay, especially some animals are known for feeling. I think of like the Lion King. When they get the morning, I think it's the morning report when the little gopher comes out of the ground and gives it, and he said, and they talk about the herd is on the move, and the animals could feel the vibrations moving. Some animals are very much notorious for knowing, like if an earthquake or something's going to occur, they go to safety before it happens, as they feel it before it actually happens. They feel it before it actually happens. Or lower.
lower.
Yeah. An earthquake is an infrasonic wave. Is an infrasonic wave.
So it's less than 20.
Yes. Now, what have everyone done? I would almost bet in their entire life that deals with pitch.
Same.
Have you ever demonstrated different pitches? I can't really sing at all either. I mean, I tried to join the singing. I tried to join the choir and got told no. Yes, I'm very famous.
Have you heard of Danny Laurel?
No.
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 Look it up.
But what I will. When I go with this, when you're in elementary music, do, re, mi, fa. You know what I'm talking about?
Yeah.
That is going from low pitch to a high pitch. Okay, that's what you use to demonstrate the different pitches. And like same thing with like if you like playing a note, like a musical note is a pitch. Okay, a musical note is a pitch. So anybody here in band know anything about music? Ashton? And like B flat, isn't that a sound? That corresponds to a certain pitch. Okay, that corresponds to a certain pitch. I know very little, nothing about music.
Like instruments, they
Mm-hmm. Yeah, and like and how do you change the pitch? Like I think like a guitar, you change the pitch based on where your finger is located. Okay, if you change the length of the vibration, it changes the pitch. It changes the frequency, which in turn changes the pitch. Using sound. Okay, using sound is used all the time. Like we're talking about an ultrasonic wave. Okay, we can't hear it, but that's still using sound. So we did that in an ultrasound. Sonar and echolocation use sound waves. Sonar and echolocation are very, very similar. Okay, an echolocation typically occurs above the ground. Okay, and sonar typically occurs in water. Is typically the main difference between sonar and echolocation.
Don't dolphins use sonar and bats use echo?
Yes, dolphins use sonar. Okay, and bats use echo because bats are above the ground and sonar is below the ground. So the two types of sonar would be active and passive sonar. An active sonar is where they actually send a sound out, okay, and then they wait and get the reflection of it, okay. So they send the sound out and wait for it to reflect to figure out where stuff is. Passive sonar doesn't send the sound out. It just analyzes the ones that come in. Okay, it analyzes the ones that come in. Radar is a type of echolocation. Okay, radar is a type of echolocation. It is very, very much improved. Okay, it's very much improved. Pearl Harbor could have in some ways been averted if the radar system was better. They had just put a new radar system up at Pearl Harbor, and the people who were actually responsible for judging the radar thought it was actually a flock of birds.
I thought it was a flock of birds.
Because you really couldn't tell a difference between at that point in time with the radar. Yeah, and so it was a very large mistake that those people made, but it's something that happened before. Something had shown up on the radar, and they said something out.
Picked up everything at the time.
Yes.
Not a certain size.
Bingo. Ships use sonar. They use underwater. And typically, I would probably say one of the greatest advancements in radar that occurred were during World War II. Okay, because that became a very large advantage we had that the Allies had because our radar became better, so we could see the German planes coming before they got close enough to ready our air defense system.
So can there be like a hurt and murder? Could there be a way you can speak into something and it goes at a higher pitch over human and something converts it?
I mean, it's just like a death call. Bring it to the death call and it comes out at a different pitch.
Listen to him.
Really? Like, I'm saying, like, is there a way you can communicate to each other using the higher pitch?
Are you trying to say like a higher pitch?
Let me ask you a question. You use a cell phone?
Yeah. Okay.
Absolutely. Maybe not pitch. You don't typically talk about pitch as much as you talk about because pitch is the human perception of that. Talk about the frequency end of it. But yes,
Have you heard of Smarter Every Day?
no,
Okay.
not smarter every day though. I not.
You're calling someone, your phone's right by each other. Why does it start going, like, making weird noises?
Because of the interference patterns of frequency.
There's a guy who toured
I do that on
a
purpose sometimes.
submarine for, I think, the Navy. And he's basically talking about a bunch of sonar and stuff. It'd be a good idea if you could show that.
They use sonar things and finding
I was a
doors,
big
I think.
fan, I would.
Yeah. All right. Last thing we talk about today is the Doppler effect. Okay, the Doppler effect is defined as the change in pitch or frequency due to the relative motion of the wave source. Your most common example of the Doppler effect is you can tell if an ambulance is coming or going based on the pitch. Okay, you can tell if the pitch is getting higher, it's coming closer to you, and as the pitch starts getting lower, it's going further away from you. Okay, is this the only place where Doppler effect is used?
No.
Where else?
It's like a race track or something.
What? Radar, Doppler radar, both of you. Okay, Doppler radar is the same thing, and that's why you see sometimes if you look at the radar, there are some false readings on the radar based on how close it is to the radar system. So if you ever look, like a lot of the times it's showing like a place in southern Illinois is always raining. If you look at the radar, even though it's not, it has a little bit of green on there.
So what is surround system fall into the Doppler effect as well?
A surround system, like surround sound. No, surround sound really typically falls more into being interference, being want to be in phase. So you want to be in phase. Because you really can't tell whether you're coming or going. Okay, it just surrounds you all the way. And they really what they try to do is decrease the Doppler effect with that.
The Doppler effect thing that's on the side of the road, and when you go past it, it tells you how fast you're going.
That's a radar. That is a radar. Now the Doppler effect uses a lot of radar. I just watched a young Sheldon the other day. He actually dressed up as the Doppler effect for Halloween. Let me pause my video and I will.